Hello everybody, I'm Abasud and welcome to my course on IoT devices, cybersecurity and risk management. So till now we have looked into it, what is IoT device, what are different capabilities it has, how it is different from IT, and what are the risk and how the risk can be mitigated, and what are the challenges to mitigate the risk. So when we are going to the challenges, we do understand there were challenges because the devices has not been manufactured, so they support these type of risk mitigation. So that's one of the reason. So how it can be rectified? It can definitely be rectified during the manufacturing, or before the manufacturing, or just after the manufacturing. So this is what we are going to discuss in our next sessions. So let's discuss cybersecurity for manufacturers, that manufacturers of a IoT device, what they need to keep it under consideration while creating a device. It's not only about the functionalities, also what security measures needs to be incorporated into it. Let's start with it. So we'll start with first thing, which is pre-market phase. So what the manufacturer activity needs to be done pre-market phase. So manufacturer should consider performing the foundational cybersecurity activities describing here in order to improve how secureable the IoT devices is for customer. It can be increase the number or efficiency of customer expected device cybersecurity capability offered on IoT device. The activities are meant to be conducted in parallel with or as extension of a manufacturer's other pre-market activities. They also primarily impact those other pre-market activities. Some of these activities can also broader propose that cybersecurity effect should not be duplicated. Artifacts from all pre-market activity can inform cybersecurity specific actions. The more integrated these suggested activities are with other pre-market activities, the best cybersecurity is likely to be planned for and implemented in IoT devices. So how do we achieve that? We need to perform certain activities. The first is identify expected customers and define expected use case. Identify the expected customer for the IoT devices early in its design. It's vital for determining which device cybersecurity capabilities the device should implement and how it should be implement them. For example, a large company may need a device to integrate with its log management system, but a typical home customer would not. So manufacturer can answer these questions like the following. What type of people are expected customers for the device? It can be, let's suppose, a small business owner, a cyclist, a police officer, chef, home builder, preschool, electric engineer, or maybe a big industry. So all those things. Second question can be, which type of organization are expected customers for this device? So it can be individual home users, small retail businesses, large hospital, energy companies with solar farms, educational institute. So when we are doing that, we can go further. We can ask few more question. How will device be used? So for a single purpose or for a multi-purpose, embedded with another devices or not embedded, it's a single user or multiple user. Which geographical location the device is, maybe the country, judicial location. How it matters? It matters because, let's suppose there is a device, it's a camera that needs to be put on, let's suppose, the red lights, and and it totally depends on the weather. Somewhere the weather can be 50 degrees Celsius, the other location the weather can be minus 10 degrees Celsius. So it's very it's very important we know where our target audience are geographically located. What physical environment will the device be used in? It's inside and outside, stationary or moving, public or private, mobile or immobile, extreme or specific physical and weather condition, how long is the device is expected to be used, few hours, several years, or we cannot afford to stop the device at all. What dependencies on other system will the device likely have? uh, so using cloud-based third-party services for the same functionality requires use of a particular IoT hub. How might attacker misuse and compromise the device? Potential pairing of threats and vulnerabilities such as threat modeling, including consideration of network connection that may provide a path to the internet that can be used as a vector for attack against other network or devices. What other aspects of device use might be relevant to device cybersecurity risk? Operational characteristic of devices that may have safety, privacy, and other implications for the users. So this is what first activity we should be performing. Now, second activity, research customer cybersecurity needs and goals. Cybersecurity needs and goals will be primarily but not entirely driven by cybersecurity risk by face. Manufacturer cannot completely understand all of their customers' risk because every customer system and IoT devices faces unique risk based on many factors. However, manufacturer may consider expected use cases for their IoT devices, then make their devices at least minimally secureable by consumers who acquire and use them consistent with other use cases. Minimally secureable means the devices that have a device cybersecurity capabilities. Customer may need to mitigate some cybersecurity risk, thus helping to at least partially achieve their goal and fulfill their needs. So when we are going for that, we can also achieve that by asking some questions like how will the IoT device interact with the physical world? The potential impact of some of the IoT devices impact the physical world either directly through actuations or indirectly through measurements, could result in operational requirement for performance, reliability, and availability, reliance, and safety being at odds with common cybersecurity practices for conventional IT devices. How will the IoT devices needs to be accessed, managed, and monitored by authorized people, processes, and other devices? The method likely to be used by device um, customer to manage the devices are important to consider. An IoT device could support integration with common enterprise system to give customer with these system greater control over the visibility into the device. M- Making a device highly configurable is generally more desirable in an organization environment and less for a home-based customer. A home customer is less likely to understand the significance of granular cybersecurity configuration settings and thus misconfigure a device, weakening its security and increasing the likelihood of compromise. Some home customers are also unlikely to want to change the configuration setting after initial device deployment. However, some configuration settings, such as enabling or disabling clock synchronization services for the devices and choosing time service to use for clock synchronization, may be desired by many customers. Consider expectation about device lifespan and how they may impact these devices. Cybersecurity capabilities are visible over the expected lifespan. Some device cybersecurity features such as software upgrade will require ongoing deployment and effort to provide the intended cybersecurity benefit. So the next question which we can ask is, what are the common cybersecurity requirements for IoT devices? Manufacturer can identify those requirements in their use case, such as sector-specific cybersecurity regulations, country-specific laws, contractual obligations, or customer expectation and convention. So they can mindful of those requirements during device capability identification. How might the IoT device use of device cybersecurity capability to interface with the device operational and environmental characteristics? For example, device expected to be used on a low bandwidth or a unreliable network might not be able to use certain device capabilities such as secure updated mechanisms. Depending on such a network for downloading large update might saturate the device network connection, disrupting other users and take too long to get updated to the device. What will be the nature of IoT device data be? There is a greater deal of variability in data storing by IoT devices. Some devices does not store any data, while others store data that could cause significant harm if accessed or monitored by unauthorized entities. Understanding the nature of expected data on a device in the context of consumer and use case can help manufacturer identify which device cybersecurity capability may be needed for protecting device data. What is the degree of trust in the IoT device that a customer may need? Customer may expect certain device cybersecurity capability and implementation that allow for specific assurance about the cybersecurity of the device and data. Example, in some context, additional trust that data is protected could be achieved by adding protection of data in use within the device. What complexity will be introduced by IoT device interacting with other devices, systems, and environment? Complexity can be driven by new use of IoT and IoT devices, new combination of those devices with each other and conventional IT devices, and increasing interconnections among devices and systems. These complexities could mean new functionality which may have human safety or privacy implications that will be connected by networking technology to systems that do not appropriately mitigate these risks. So these are the few questions that we can ask. There are other activities as well that we will be discussing in our coming session. Thank you for joining.